Welcome to the Trig video. Trig. Okay. Most important part of Trig is this. So, I'm going to be writing this at the top of every page. Okay, so get used to it. Now, we've gone over a couple of these in class, so I would actually recommend trying these yourself first, and then we can go ahead and check to see it. So I'm going to go ahead and say this is, again, one of those pause and play. If you want to get the most out of this, that would be my recommendation. So let's get started. First thing, we got Frankie. He's sitting here. Franklin, sorry. And he's looking a little cross-eyed this time, I guess, unfortunately. And he's looking down from the X, and he has what looks like across from him is going to be the opposite, and then he also has the adjacent. So O and A, we're going to be using TOA. Okay, so we're going to do the tangent of X equals OA, opposite over adjacent. Okay, so we're using SOHCAHTOA for everything that we do here. Now, to get rid of the tangent, I need to use the inverse. Okay, so the inverse tangent is what I'm going to take of both sides. I'm going to take the inverse tangent, which is x tan to the negative 1, of tan x is going to equal, whatever I do to one side, I have to do the other, the inverse tan of 6 over 4. Okay, this is going to cancel out, so I basically just get x equals this piece here, so I got to plug that piece into the calculator. So I'm going to do that out of it off screen. I'm chugging away, plug it in, chug it out, and we get 56.3. Okay, that looks good, 56.3, and we're going to go ahead and put degrees on it because we're talking about an angle. Alright, this makes sense. It's less than 90. If it was greater than 90, we couldn't have this answer. So we get 56.3 degrees. Next. Alright, remember to go ahead and hit the pause button here. First thing I'm going to do, SOHCAHTOA. Every single time I do a problem, the first thing you want to do is write out SOHCAHTOA. That's going to help us write out what we need. Okay, kind of lagging here. There we go. Alright, so we got SOHCAHTOA written out. X up here, 17, 9.3. So here's Franklin. He's chilling, looking down, and we use from his perspective, and we're going to go with opposite, and this is going to be hypotenuse. So we have opposite and hypotenuse. It looks like we're going to deal with so. Okay, so we're going to get the sine of 17 equals opposite, which is x, over 9.7. Okay, multiply 9.7 to both sides. This cancels out over here, and we get 9.7 times sine of 17 equals x. So again, I have to go ahead and put in my calculator, so just give me a second. 9.7 times sine 17 equals 2.8. Now, if you're getting different answers than me in your calculator, double check to make sure you're in degree mode. If you're not in degree mode, you could have an issue. And if you're having problems with your calculator, make sure you talk to me about it in class so I can help you figure out what's going on with your calculator. There's a big part of this that has the calculator, so make sure you're clear on that. Alright, here we go. Here's another one. Again, first thing I do, SOHCAHTOA. Go ahead and get that written in there first. Haven't had a cosine yet. Hopefully this one might be one. Go ahead and pause it and try it. I got Franklin, he's here. Franklin's getting better looking eyes each time. I love it. Okay, little eyebrows. There we go. From Franklin's perspective, I have the hypotenuse, which is here, and the adjacent piece. So we're finally hitting cosine. So we're going to take the cosine of 35 equals, okay, and this is adjacent, which is 7 over x. Okay. Now, a lot of students have trouble with this one because x is in the denominator, and they're like, I don't know what to do, Mr. Smith. Well, we want to get rid of the x. from here. So we're going to go ahead and actually multiply the x out. The problem with that is it leaves x with cosine 35 equals x, or sorry, 7. X is still not alone, so I have to go ahead and divide by the cosine of 35 to both sides. That's going to cancel here, so x is going to equal 7 over the cosine of 35. Now this one you have to be really careful plugging into your calculator. Okay, so we get 7 divided by, use parentheses in your calculator, and then do cos of 35. So make sure you got that parentheses built in. And we should get x equals 8.54. Okay, so that's what we should get. And that sounds reasonable. It's bigger than 7, so it's the hypotenuse. That makes sense. If you didn't put that in there, there's a potential you could get a slightly different answer. Okay. Basically what happened is the cos of 35 just changes places with x. Notice these two kind of just swapped. Okay. So if you can kind of remember that, it saves you a little bit of time, but we just solve for x by multiplying it out, then dividing by the cos of 35 on both sides. Alright, here's another one. First things, so, ka, toa. You're going to be so good at writing this every single time. Every single time. Alright, we got Franklin, he's down here. Kind of looking like a frog, maybe a turtle. We don't have opposite, but we have adjacent and hypotenuse. Okay, so this is a great problem again for cosine. But again, we're going to take the cosine of x equals adjacent over hypotenuse. Okay. Again, I'm trying to find the x, so we have to use inverse cosine. So I'm going to multiply both sides by the inverse of cosine. And when I do that, I basically end up with the cosines crossing out over here. So x is just going to equal this piece. So this is what I'm going to plug into my calculator. Okay, so the inverse cosine of 4 divided by 8. Okay, and you're going to get 60. Okay, this is very interesting. I got 60 degrees right here, which makes this 30. Hey, isn't this a 30, 60, 90 triangle where 4 would represent x, this would represent 2x, so this would represent x rad 3. Okay, so it's kind of cool that you can actually solve these. This is a special right triangle. We didn't know that because x was unknown to us, but we actually had that relationship of x to 2x and x rad 3, so it's kind of cool that we were able to do that. Alright, last problem. This one's a doozy. This has got 2 triangles in it. Okay, pretty tricky. And what we have to do is we actually have to look at the large triangle first. Okay, and I'm going to look at this large triangle first. In the large triangle, we're going to put Franklin over at the 32. There he is. But he's only looking at the large triangle. Opposite the 32 is 24. That's opposite. And adjacent to 32 is A. So again, I forgot to write SOHCAHTOA. Always got to write that. Don't want to mess that up. But we have O and A, so we're going to actually be able to solve for x first by using tangent of 32 degrees equals opposite over adjacent. Okay. Now, if you remember a previous problem that we just did, I was able to multiply the x out and then divide the tan 32, but essentially these two are going to switch places. So what happens is I end up with x equals 24 over tan 32. Now, if you don't believe me, I showed you the math on the last problem, but you multiply the x out on both sides and you get x on the left side and you got to divide by tan 32. So this works. We got to go ahead and plug this into our calculator and see what we get. Okay? So we get 24 divided by, I'm going to use parentheses, tan of 32, and we get 38.4. Okay, so there's x. So I'm going to go ahead and I'm going to erase my opposite and my A, and even Franklin, I'm going to have him disappear for a minute. And let's go ahead and plug in that we got 38.4. Okay, so there's X. Now I want to find Y, but I want to do it without having to use X if I don't have to, but I might have to. So basically, if that's a 90 over here, I'm going to have a 90 right here. 32, I know that if I do this correctly, we should get an angle measure of 58 degrees over here. Okay. Now it doesn't matter, I didn't have to solve for that. I could still use the 32, but now that I know what X is, I can actually go ahead and find Y. So I'm going to go ahead and clear this space so I have some more working room. You can probably just move your page down and you'll be fine, but I just need some more room. Okay, I'm now going to look at the smaller triangle. Okay, so I'm only looking at the smaller triangle. I'm going to try and make it really clear. I'm only looking at this triangle now, not the full triangle. Okay, and I'm going to just switch it up a bit, and I'm going to put Franklin. He's up here, and he's got super dark eyes this time, but he's up here. He kind of looks sad, but he's happy, you know, for the most part. And let's see what we have. Okay, according to this, we are going to have Y is what we want, which is opposite, and now X is the hypotenuse. Okay, we're going to use 38.4 for right now. We rounded it, so it's not going to be super accurate, but I can show you a little trick of how we can get it to be pretty accurate. So here we go. Opposite and hypotenuse, that's going to be so we're doing the sine of 58, okay, equals opposite over 38.4. Multiply that out, and we get 38.4 times sine of 58, and that will give me the value of Y. Now, like I said, what I would do is in your calculator, you probably might still have this number sitting in there. And if that number is still sitting in there, you can just hit multiply sine 58 instead of doing 38.4. So I'm going to show you the two different answers, okay? So this one is going to be with the in calculator, and this one's going to be the rounded one. Okay, notice you're going to have two different answers. So I have it in my calculator. It was in there already, then I hit multiplied the answer of the previous one, sine of 58, and I get 32.57. And then if I round it, if I just type in 38.4 sine of 58, let's see what I get. I get 32.56. So pretty close. Not that big of a difference. I wouldn't worry too much. But there's our Y value. Okay? There it is. And this makes sense. 32 is less than 38. 38 is the hypotenuse, so it seems to be in good order. Okay? Thank you guys for watching the video.